bevel gear. So bevel gear looks like this. We all know this. We all have Google bevel gear, but why is the name is bevel gear? So bevel. You guys know bevel, right? You guys know bevel? No, what? Bevel. Why is called bevel gear? Because the angle. So bevel synonym. Synonym for bevel can is also chamfer. Chamfer. It's a little bit different, but it's like chamfer. So MB akan datang bagi jam baca lah. So now that we have know why it is called bevel gear, we are no more a noob engineer. So this is the surveys of the technical literature that I have found about forging a bevel gear. When I Google forging bevel gear, there's a lot of literature actually, but only some that discuss very specifically about forging bevel gear or forging gears. Some just about the numerical that's mean for the CNC lah. So I don't want that. So when I shortlist the literature is this cold and hot forging fundamentals and application by Thailand Alton, edited by Thailand Alton, and investigation into the rotary forging of a bevel gear by MB Yusof. This one is a thesis from UMIS at the year 1990, and the art of gear fabrication by Prem H. Daryani. Prem H. Daryani is a very experienced people in the industry. So he will be talking a lot about the designs, how to minimize the cost. So very useful reads. I haven't read it, just the review. And then last one, the steel forging design, production, selection, testing and application by Edward G. Nisbet. So that's all about the technical literature survey. If you guys want to read, please jot down the picture and read by yourself. So now let MB give his picture. Let Mr. Hazran. I will let Mr. Hazran to continue this forum by explaining about the bevel gear process, manufacturing process, right? Okay. So, Assalamualaikum dan salam sejahtera semua. Okay, when we talk about bevel gear forging process, we just need to understand that bevel gear actually is using the same concept of mortar and pestle. You know, in Malay what we call ada lusung dengan lusung lusung batu. Bila we call lusung batu, mortar and pestle. So the same concept, because we want to produce something by compressing or hammering this the workpiece. Okay, mortar and pestle, crushing the chilies, just whether this angle or this angle, but still hammering the chilies. Okay, and then just roughly first, the forging force between the mortar and pestle is the concept in this bevel gear also small, because the bevel gear, the tooth contact is small, as we already see the picture of bevel gear just now. The keyword to understand the process of bevel gear forging process, only three keywords.
the first one, we need to know what is the bevel gear forging that I told you roughly just now. And the second one is die design, the design to produce the workpiece. And the third one is the analysis of this finite element method that I already told last week, roughly. Last month. Okay, when we talk about cool forging, we know that the forging take place at room temperature. Why we call cool forging bevel gear? Okay. Sorry. Just listen. Whether you can call it. Okay, it's called cool forging bevel gear because the forged gear replace machine gear due to precision secure. Okay, dalam bahasa Melayu dia macam ni. Apabila forging tu dilaksanakan, dia memerlukan precision yang betul-betul nak accurate lah. Setiap angle dia, sebab dia punya tunjuk sikit. Can you show the picture, the previous one?
Yes.
Okay, kita boleh tengok dia punya precision dekat sini. Sama ada berapa puluh tu sekalipun, dia punya precision dan accurate dia tu memerlukan satu kriteria yang perlulah. So okay, lepas tu dia punya labor cost dia inexpensive dan dia punya production cost dia untuk simple part ni less expensive, sebab selalunya dia punya gear ni dalam automotive part pun tak besar sangat macam yang Solar buat. Okay, we directly going to gear forging process. As we can see, there are three main steps. The first one, the initial billet. The second one is preforming, and the third one is final forge part. Okay, as we can see, last Monday the process of the other forging process. Diorang asyik ketuk tau. Asyik ketuk. Lepas tu yang manual punya tu asyik ketuk. Lepas tu diorang replace pula macam tu, ketuk lagi. Bukan yang diorang ketuk tu direct jadi. So sama juga macam bevel gear process ni. Dia ada bentuk asal. Okay, bentuk asal dia lebih kurang macam ni. Initial bilik dia contoh cylindrical macam ni. Ni dia punya initial bilik. And then the second one, dia preform, dia kurangkan angle dekat sini. Lebih kurang macam tu lah. Roughly dia kurangkan angle. And then the final forge part tu yang last kali, tapi nak kata last pun tak juga, sebab macam Madam cakap itu, dia akan masuk pula finishing process untuk complete lah, untuk produk tu betul-betul dah boleh dikomersialkan. Okay, yang final forge part ni dia sama macam ni juga. Dia dah undergoes forging tu. Tak ada apa gigi-gigi kat sini, terus kat sini. Dah nampak bentuk nak jadi bentuk tu lah. Cuma apabila kita tambah dengan finishing process tu, dia punya permukaan tu smooth, clean. Wow. Okay, tapi apabila kita undergo this gear forging process yang 3 main step ni akan lead to problem. Problem dia yang paling obvious sekali, unfilled section. Unfilled section dekat gear teeth tu. Selalu kalau teeth dekat sini, contoh angle teeth betul-betul macam ni. Dekat sini selalunya akan terjadinya unfilled section. Dan disebabkan this, because of this unfilled section, we need to control the plastic flow. We call that plastic flow process. As I said just now, there are 3 main criteria. Bevel gear forging process. Second one, die design. And the third one, finite element method, FEM. As we see just now, this is the process, and the second one is about the design, the die design. The die design plays an important role because when we punch something, let me see that the schematic diagram. Just like this. This is the punch. This is the punch, and this is the punch. This is the part, and this is the die. When the punch the workpiece, guys. When the punch forge the workpiece, then the workpiece will spread out. And then the force in the workpiece will spread out to produce the shape. But as the pin here only one pin. The force that spread out, not what we call not scatter. Not equal. So the die design that already modified to produce the equal force by using the both pin. So they are already the die design, they're using the both pin. So when the punch press, and the other also press a force, so the workpiece will go equal to every space of the die. When we use both pins. Only in the bevel forging process.
Thank you, Mr. Azlan, for
I leave you.
we don't have time here.
So, I think that's all.
Sorry.
It's okay.
So now we will hear Mr. Amir will explain to us about the why do we use forging, the comparison forging and casting to make a bevel gear.
So my part I have to ask about forging versus casting overseas. As you know, forging is more strength than casting. But why? The question is why? Pressure. The pressure, casting is a pressure. So we can say here that the forging part is made by forging plastic deformation. First information, there are the residue stress. You know what is residue stress? Residue stress?
Yeah.
You know when I want to do this again. You know when just that just a metal, standard metal gum, right? Yeah, past information here, right? So the residue stress is here. This is residue stress. You know that? So there are residue stress.